look at this beautiful cake I made. It's so beautiful. Look how pretty.
Since Julia was walking in the x direction, the initial velocity will be the same as when she was walking.
If the cake only had velocity in the x component, why didn't it travel straight?
Gravity acts on all objects. As soon as the cake left her hands, it flew in the x direction, but gravity will pull the cake downwards.
Julia's cake throwing can be expressed as a projectile motion problem. The height of the balcony being 5 meters and the horizontal launch velocity of the cake being 4.00 meters per second can be used to find the horizontal distance, the time until the cake hits the ground, and the impact velocity. First, write out the givens. Include a reference frame with labeled positives and negatives. In this case, downward will be positive and right will be positive. Make sure to include this for any angled problems because sometimes the motion is up and sometimes it is down. We know that the distance in the y direction is 5 meters, that being the height. The velocity in the horizontal direction, v1x, is 4 meters per second. We know the acceleration in the x direction is 0 meters per second squared, and the downward acceleration, ay, is 9.81 meters per second squared. We also know that the velocity in the y direction, v1y, is 0 meters per second. First, find time to hit the ground using the given formula. Delta dy equals 1/2 ay delta t squared plus v1y delta t. We know that v1y equals 0 meters per second, therefore it can be cancelled out. We are now left with delta dy equals 1/2 ay delta t squared. Isolate for t, therefore having square root of 2 delta dy over ay equals delta t. Now plug in the givens. 2 times 5 meters over 9.81 meters per second squared, all square rooted. Plugging this into the calculator, we will get 1.01 seconds. Okay, that's it. In the second problem, we will find the horizontal distance traveled. Now knowing delta t, we can use the same formula from the previous question in the x direction. This formula being delta dx equals 1/2 ax delta t squared plus v1x delta t. We know that ax is 0 meters per second. Therefore, we are left with v1x, with delta dx equals v1x delta t. When plugging in our givens, we will get delta dx equals 4 meters per second times 1.01 seconds. This will give us 4.04 meters. In the third problem, we will be finding impact velocity. To find impact velocity, v2x and v2y must be found. Since v1x equals v2x due to no acceleration in the x direction. Therefore, v2x equals 4.00 meters per second. v2y can be found using the equation v2y equals v1y plus ay delta t. Since v1y is 0, it can be cancelled out. v2y equals 9.81 meters per second squared times 1.01 seconds. This gives us a total value of 9.91 meters per second. The impact velocity is found using Pythagorean theorem. v2y in the downward positive direction and v2x right positive direction can be used to find v final. The v final equation is v final equals the square root of v2x squared plus v2y squared, all square rooted. This is derived from the Pythagorean theorem formula. Then the givens can be plugged in. This would be equal to 4 meters per second squared plus 9.91 meters per second squared, all square rooted. This leaves us a value of 10.69 meters per second. This is our final velocity speed. Because velocity is a vector, the angle must now be found. This can be the tan equation is expressed as opposite over adjacent. This can be written as v2y over v2x. Plugging in our givens, this gives us 9.91 meters per second over 4.00 meters per second, giving us an angle of 68.02 degrees, or in 3 sig digs, 68.0 degrees. Therefore, our final velocity is 10.7 meters per second, 68.0 degrees below the horizontal.
Hey Julia, what are you doing? Playing with the ball my mom bought me for passing my physics test.
When Julia is throwing her new toy ball, she is demonstrating the simplest form of parabolic motion, straight up and down. When Julia throws the ball, you notice that the ball will have a max height before it comes back down. At this max height, the velocity is 0. This is true for all projectile motion. For projectiles that exhibit a straight up and down motion, the velocity at the max height is the same as the velocity when the object is at the bottom.
When Julia is walking while throwing the ball up and down, there are 2 points of view. In her frame of reference, the ball moves straight up and straight down, but in the viewer's frame of reference, it moves in an arch. Both are right. In both cases, at the max height, the velocity is still 0.